Let's have a look at the next question. State what is meant by specific latent heat of fusion or specific latent heat of melting of a substance. Specific latent heat of fusion or melting is defined as the amount of energy required to change the state of unit mass of a material. And since the word here is fusion or melting, we can change the state from either solid to liquid, in which case it's called melting, or liquid to solid, in which case it's called fusion. Next, ice cubes of total mass 70 gram and at 0 degrees Celsius are put into a drink of lemonade of mass 300 gram. All the ice melts as 23,500 joules of thermal energy transfers from the lemonade to the ice. The final temperature of the drink is at 0 degrees Celsius. Calculate the specific latent heat of fusion for ice. As I've declared here, the specific latent heat is given by the formula Q is equal to ml. Here Q is given as 23,500. M is given as 70 gram in SI units, which is 0.07 kilogram times L. L is the value of specific latent heat, which can be found out to be 336 joules, 336 joules or kilojoules, let's say, per kilogram, or 336 joules per gram. The thermal energy that causes the ice to melt is transferred from the lemonade as it cools. The loss of thermal energy causes the temperature of the 300 gram of lemonade to fall by 90 degrees Celsius. Calculate the specific heat capacity of the lemonade. Now, specific heat capacity can be found out by the formula Q equals M times C times delta T, where Q is the amount of energy that is supplied and M is the mass and delta T is the change in temperature. So here Q is again found out, or in fact taken from the previous part, 23,500. M is given as 0.3 kilogram. C is an unknown yet to be found out. Change in temperature is 19 degrees Celsius. Simplifying this and making C the subject of the equation, we get the specific heat capacity to be 4,100 joules per kilogram. Moving on to the last part. The melting ice floats on top of the lemonade. Explain the process by which lemonade at the bottom of the drink becomes cold. As we know that ice has a lower density, which is why it floats on top of the lemonade. And as ice starts to float on the top layer of the lemonade, ice is of a lower temperature. And as ice starts to increase its temperature, or as it begins to melt, it absorbs the energy from the topmost layer. And as it absorbs energy from the topmost layer, the water in this topmost layer becomes denser and it sinks. And as it sinks, the bottom of the drink becomes cold. This is exactly how the process is carried out.